So we're gonna do two presentations per session. So we're gonna have BJT for group number 1 today, and followed by JFAT by group number 2. So we're gonna do presentation for 20 minutes for each group, and then followed by 5 to 10 minutes of Q&A, depending on the number of questions. And yeah, we're gonna be done with 2 groups for each session. Okay. So you have already looked into the assessment rubric, right? Okay. So this group presentation will be contributing to 30% of your coursework mark. And you're gonna get your mark as a group, not individual mark. Okay. So if your group gets, say, 25 out of 30%, so that means the whole team is going to get 25%, provided each and everyone in the group contributes. So that's why, yeah, you can start turning on your camera now, especially for group 1. Provided your name is on the list, right? You have to make sure that your name is on the list. So after the presentation, I want the group leader to email to me your PDF of your slide. Okay. Convert your PowerPoint into PDF, email to me, and then I will share on eLearn, right? I'll share on eLearn, and everyone gets to access, right? So the whole objective of this session is to share and to get everybody to access the very same information, right? So let's get started. Group number 1, the group leader will be Amirul, and then they'll be presenting BJT, Bipolar, Junction, Transistor. And let me mention the group members here. We have Rafai, we have Amirul as group leader, we have Akila, we have Arisha, and also Cornelia, right? So altogether 5 group members. So without further ado, I would like to pass the floor to the group. So let's welcome group number 1. Let's clap anyway, because since you cannot learn, you cannot listen in the hall, but let's just clap anyway. Round of applause to group number 1. So the floor is yours. Go ahead.
Hi, and a very good afternoon I bid to the Dr. Zamir and all my fellow friends. So my name is Ahmad bin Mat. We'll together with Amirul, Arisha, Cornelia, and Akila will present the topics for one of the semiconductor devices, which is bipolar junction transistor, or BJT. So this is our scope presentation that we are going to discuss today. Consists of introduction, device configuration, working principle, and also the application. So next. So this is so I'm going to cover the first part of the BJT, which is introduction. So why the name of BJT is this? Because the operation of BJT involves the conduction by 2 carriers, electron and holes. So instead of the BJT, this BJT is formed by combining 2 junction diodes, and is also formed of either a thin layer of P-type semiconductor between 2 N-type semiconductor, or a thin layer of N-type semiconductor between 2 P-type semiconductor. So this kind of, for the formation of BJT. So the history of BJT, the first bipolar transistor is invented by the 3 scientists, which are William Shockley, Walter Brattain, and John Bardeen. So due to the contribution of this invention, they were awarded the Nobel Prize in 1956. And the term transistor is derived from the words transfer and resistor. These were also described the operation of BJT, which is the transfer of an input signal from a low resistance circuit into a high resistance circuit. So the third one is the symbol of BJT. BJT consists of two symbols, which are NPN and PNP respectively. So based on the symbol, the left side, this is the NPN transistor, because we can see that the arrow is flows into the emitter. So this is the NPN transistor, and the right side of the graph of the picture is PNP transistor, because the arrow from the emitter to the base. Okay, next. Okay, so what is BJT? So the BJT is the three-terminal semiconductor device that consists of two PN junctions, which are able to magnify or amplify a signal. It is also a current control device. So speaking technically, BJT is a terminal device that consists of 3 feet. So the transistor have 3 feet, which are the emitter, base, and also the collector. And the current flow through the emitter and the collector are controlled by the amount of current applied to the base. So the term bipolar in BJT, bipolar, comes from the fact that this type of transistor contains two types of semiconductor material, one positive type or P-type and one negative type, N-type, through which current flow. So in BJT, there are three dope regions. For NPN, EC dope with N-type impurity, and B is dope with P-type impurity. And the second one is PNP. So the B dope or base region dope with N-type impurity, and collector and emitter dope with N-type impurity. So this is the introduction about the BJT. So to go more detail about how these devices operate, how the configuration of the device will be taught by Amirul Firdaus. So take it away.
Okay, thank you, Rafai. Okay, before I start into the configuration, I want to set up things straight. In the emitter, the NPN type, the emitter is heavily doped, the base is slightly doped, and the collector is moderately doped. Okay, so we go into the BJT configuration. The first one is common base, the second one is common collector, and the third one is common emitter. So what are they? Okay, as you can see in this common base, sorry, as you see this in this common base, this is the configuration of the common base. So as you can see, the most common application of BJT is used as amplifier. As you can see, the emitter terminal is common between the input and the output. Okay, and then in this NPN transistor, the applied voltage should be such as the emitter base junction get forward bias and the collector base junction get reverse bias. And at this NPN transistor, you can see the direction of the current look like this. That means the emitter current will go away from the transistor, while the base current and collector current will enter the transistor. In this common base configuration, the behavior can be described that have two characteristics, which is input characteristic and output characteristic. I want to tell you why the graph is slightly shift to the left on the input characteristic. The reason behind that, because the collector base junction gets more and more reverse bias, so the depletion region will increase. So due to that, the base region will get narrower. So the less voltage is required to forward bias the emitter base junction. And due to that, the curve shifts slightly to the left hand side. From the input characteristic, we can find that the impedance of the device in this particular region, if we find the slope of the curve, we can see the impedance, input impedance region. So next is the output characteristic. The output characteristic can be shown as three regions: the active region, the saturation region, and the cut-off region. In the active region, we can see this is where the amplifying region. So the output characteristic define the relationship between current collector, the IC, and the VCB. This, if we change the VCB, the VCB, is it? If we change the base voltage, the collector current will also change. So as you can see, the emitter current increase, the collector current also increase. Okay. So next we go into the common collector. So this is the common collector. In this configuration, the collector terminal is the common for both input and output signal. This configuration, because the emitter voltage follow the base voltage. This configuration most usually as a buffer. This configuration are widely used in impedance matching application of the high input of impedance. So I want to talk about the output characteristic and the input characteristic. The output characteristic is IE and VCE. Because, okay, as you look at this difference between IE and VCC curve, it is very similar to common emitter that I will talk later. As because of here, the emitter current can be given as alpha time IC. Emitter current alpha time as IC. So due to alpha, which is the current gain, is unity, is approximately close to 1. So we can say that IC is equal to IE. So so because the VCE can be given as VCB plus VCB. So as we increase VCB, the width of the depletion region will also increase. And due to the depletion region is increased, the effective base will reduce. And as if the effective base width reduce the probability of recombination in the base reduce the probability of recombination in this base region will reduce, and due to that, the base current also be reduced. That means when the VCB increase, the IB reduce. For the fixed value of VCB, as we increase the voltage of VCE, in other words, as we increase the VBE, then the base current will be increased. Because as voltage base emitter increase, more and more electron will be pushed by this emitter terminal, and due to that, the base current will increase. This means when the fixed value of voltage VCB, as we increase the VCC, then the base current IB will be increased. In another word, for bigger value of VCE, the entire curve will shift on into the right hand side. The next one is common emitter. So we can see that the emitter is the common place for input, which is base, and the output, which is collector. So we can see that the base emitter junction is forward bias and collector base junction is reverse bias. As you can see, the input characteristic for a common emitter is IB and VBE, and the output characteristic of IC of common emitter is IC and VCE. So so similarly to the so in this input characteristic, the different IB and VBE curve are shown. So as you look at the curve, they are similarly to the forward characteristic of PN junction diode. Because if you look over here, the base junction emitter is put aside as forward bias. And when we increase the VCE value, the base current reduce. So it's the same as the base the common collector, that when we increase the VCB value, the depletion region will get wider, and due to that, effective base width will reduce, and due to that, the probability of recombination in the base will reduce, and due to that, most of the electron will get collected at collector terminal, so that the base current will be reduced. So I think that's all for me. Now we go to this. This is the summary of what I just said just now. Okay. Then we go to the working principle by Akilah.
Thank you, Amiro. So I will talk about working principle of BJT. Amiro. Hello, boleh dengar tak?
Boleh Akilah, saya boleh dengar.
Okay. So NPN transistor, the majority carrier is the electron, and the minority carrier for NPN transistor is hole. So BJT have two functions formed by the combination of two back-to-back junction. Base emitter junction is in forward bias, while the collector base junction is reverse bias. So at PE junction, the potential barrier decreases with the forward bias, and the depletion region also will be narrow compared to the collector base junction. So the electron will start flowing from emitter terminal to base terminal. So this current known as emitter current. As the base is lightly doped, so very little number of electrons from emitter terminal combine with hole in base terminal. Due to combination of electron and hole, current from base terminal will start flowing, known as base current. So base current is about 5% of emitter current. So the remaining electron will flow from reverse bias collector junction, known as collector current. The next, Amirul. PMP transistors. So the majority carrier for PMP transistor is hole, and the minority carrier is electron. In PMP, PE junction is connected in forward bias, while CB junction is connected in reverse bias. Very large number of holes from emitter cross the depletion region and enter the base. Simultaneously, a very few electrons from the base will enter into emitter and recombine with hole. So this is because the depletion region in BE is narrow as in forward bias. The current flow through BE junction is known as emitter current. The remaining hole which do not recombine with electron in base will travel further into the collector. The collector current flow through BB junction due to the hole. Okay. Next, I will pass the phone to talk about prediction of BJT.
A very good afternoon to Dr. and all my fellow friends. In this section, I'll be talking about application. There are 4 applications, which is temperature sensors, high-speed digital logic, and the 2 other applications will be talked by my friend Arisha, and we'll be also talking about 2 companies that manufactured BJT. So next. So my name is Cornelia Colin, and I'll be talking about the application of BJT part 1. Next. So these are the temperature sensors. The most common types are these 4, which is thermistor, resistance thermometer detector or RTD, thermocouple, and semiconductor temperature sensor. But in this section, I'll be talking specifically on semiconductor temperature sensor. Next. So what are the functions of temperature sensors? So as a general, temperature sensors are devices to measure temperature readings through electrical signals. So it is commonly categorized based on mode of connection, which are contact and non-contact. So as in the name as well, contact means indirect contact with the object they are measured, and the non-contact, they measure using thermal radiation released by heat sources, for example, a nuclear power plant. In geotechnical monitoring, temperature sensors also measure the heat of hydration in mass concrete structures. So there are pros and cons in temperature sensors. The first one is it is inexpensive or cheap. It is very linear with accuracies of positive negative 1 degree Celsius. It is also low power consumption and moderately small in size. So thanks to its small size, these semiconductor temperature sensors can be installed directly on PC boards, underneath high power integrated circuits, and etc. So it is ideal for embedded applications. So also there is cons. It is less sensitive. It has a limited temperature range within negative 50 degrees Celsius to 150 degrees Celsius. So this limited temperature, it means it cannot withstand high temperatures and not free from self-heating. It is also have low stability, which means low durability, as it can drift over time, depending on the materials, of course. And it also has low response time, 5 to 60 seconds, and it has electrical and mechanical performance that is not very robust or not very wide in range. So next. So these are the examples or the most popular BJT. sensors include AD590 and LM35. AD590, which is on your left, it is manufactured by a company called Analog Devices Incorporated from Wilmington, Massachusetts, USA. And the right side, LM35, it is normally manufactured by a company from Texas Instruments from Dallas, Texas, USA. Next. So in these temperature sensors, they also have sensing elements. So the semiconductor temperature sensors come in three types, determined by the output signal as they produce. The first one is the analog voltage and current output sensors. This one is the oldest type, and it also can detect temperatures using Celsius or Fahrenheit scales. And the second one, this is the logic output sensors, and this is designed to detect a preset temperature like a home thermostat. In Malaysia, we don't have home thermostat, but it is usually common used in four seasons countries. And the third one is the digital or serial output sensors. So next. So this is the second application for BJT. Specifically, I'll be talking about emitter-coupled logics as a high-speed digital logic. So what is this? It is a high-speed integrated circuit bipolar transistor logic family that uses an overdriven BJT differential amplifier with single-ended input and limited emitter current. So we take to history. It is invented in August 1956 at IBM. IBM is an International Business Machines Corporation by Hannon S. York. IBM is headquartered in New York with operations over 170 countries. ECL is originally called as current steering logic, and it was used in IBM 7090 and IBM 7094. If you are wondering what are these type of computers, these are mainframe computers used primarily by IBM for critical applications and bulk large organizations. So there are pros and cons as well for ECL. The first one is it is the fastest logic family and with high speed operation. It also reduces storage delay, fan out capability, which means the number of inputs can be connected to a specified output is very high, and it does not vary much with temperature, which means it independent of temperature. So the disadvantage of ECL, it's a tad bit expensive and with the highest power dissipation among all logics. So next. So this is just the explanation of operation. Using to input ECL, OR, and NOR gate. So next. So this part where my friend Arisha will be talking for amplifier and switch.
Okay, Assalamualaikum. Are you guys hear me? Okay. So now I will talk about.
Yes, I can.
So now I will talk about the application of BJT as an amplifier. So amplifier are circuits that are used to increase the intensity of a signal depending on the application. The applied input can be either voltage or current signals. This amplification process is used in radio signal and long distance communication. So a transistor must be efficient in terms of gain and linearity. The transistor circuit for the amplification is designed in such a way that the input is always applied at the junction that is forward bias. So the output can be collected across the reverse bias junction of the transistor. So the reason is it provides the results of amplification accurately. At the input side, the transistor is provided with a low resistance value. Because of that, it can provide the changes in the output value if there is any significant change in the input signal. So even the DC voltage can be applied to the circuit. In this way, the low value of the signal is applied at the input because of the internal circuit design. The output signal possesses the strength of the output signal as high. Overall, the circuit design here acts as amplifier. So the electronic circuits generally utilize the NPN NPN type of BJT. It is considered to be the most frequent used one. The common emitter configuration is chosen because of its gain capacity. The input side can be consist of the resistor connected in such a way that is form a potential divider circuit. This kind of bias is most frequently used in the amplifier that are designed with the help of BJT. So now the transistor working as an amplifier has various advantage and application in the field of electronic and communication. So the first one is it can be used in long distance communication because of the intensity of the signal obtained at the output. So it will be high. In the radio signal amplification, these transistor amplifiers are utilized. And the third one, the amplifier play a prominent role in wireless communication. Next slide, Amira. So now the application of BJT as a switch. So depending on the biasing condition like forward or reverse, transistor have three major modes of operation, namely cut-off, active and saturation regions. The cut-off region has the operating condition when the output collector current is zero base input current and maximum collector voltage. So these parameters cause a large depletion layer which further doesn't allow current to flow through the transistor. Therefore, the transistor is completely in off condition. In saturation region, a transistor is biased in such a way that maximum base current is applied that result in maximum collector current and minimum collector emitter voltage. This causes the depletion layer to become small and to allow maximum current to flow through the transistor. Therefore, the transistor is a fully on condition. So we can say that the transistor can be made to work as on and off solid state switch by operating transistor in cut-off and saturation regions. This type of switching application is used for controlling LEDs, motors, lamps, solenoid and others. Next slide, Mira. So this is the example of BJT as a switch for the LED. So the schematic diagram show how a transistor is used to switch the LED. So when the switch at the base terminal is open, no current flows through the base. So the transistor is in the cut-off state. Therefore, the transistor acts as an open circuit and the LED becomes off. When the switch is closed, base current starts flowing through the transistor and then drive into saturation, which result in LED turn on. Resistors are placed to limit the currents through the base and LED. It is also possible to vary the intensity of LED by varying the resistance in the base current path. Next. Okay, Con.
So in this section, Arisha and I will talk about companies that manufacture bipolar junction transistor. The first one. So for the first one is the ON Semiconductor Corporation. Its HQ is at Phoenix, Arizona, USA, and it was founded in 1999. So most of the products they manufactured are power and signal management, logic gates, discrete and custom devices for automotive communications, computing, consumer, industrial, LED lighting, medical, military, aerospace, and power applications. So ON Semiconductor Corporation has a lot of R&D, especially for manufacturing facilities. They have 10 manufacturing facilities, and one of them is at Senawang Negeri Sembilan. So in Senawang Negeri Sembilan, they manufacture discrete small signal, power bipolar, rectifier, and MOSFET technologies. And this ON Semiconductor Corporation is also in the Fortune 1000, and it was ranked 512 in 2020, and it was nominated as world's most ethical companies. So next.
So the second companies that we found is Nexperia. So Nexperia has a global footprint, and it is the headquarters, the HQ of Nexperia is located in Nijmegen, Netherlands. Nijmegen. So they have numerous offices serving each of the three global regions, Asia, Europe, and America, all in close proximity to their customers. So there are five Nexperia manufacturing facilities, and these include their own wafer fabs in Hamburg, Germany, Manchester, UK, and also the assembly centers in Guangdong, China, Seremban, Malaysia, and Cabuyao, Philippines. And also, there are R&D centers located in Nijmegen, Netherlands, in Hong Kong, and also Penang, Malaysia. There's I put the address. I think in USM, so I think it's near us. So next, Mirul. So this just the picture of the maps Nexperia sites. So you can see this, and next slide, Mirul. And this the type of bipolar transistor that produced by Nexperia. So I think that's all from us. And if you guys have any question, you can ask. Any student?
All right, thank you very much. All right, so let's open for a brief Q&A by the floor. Anyone with questions? You can unmute yourself and ask. Anyone got any question at all? Go ahead. Anyone? Haziq, ada soalan ke Haziq? Kau terlupa unmute. Lupa mute.
I'm trying to ask question, but I forgot.
Yep, go ahead. Yep.
But all in all, I think I have question for Cornelia part. I think.
Okay, Cornelia. All right.
Mirul, can you open that slide again about the application one?
Okay, all right.
this
Application, all right. Okay.
a nitpicky thing to ask. No.
Which one? The temperature sensor, is it?
Yes, the
Which part?
temperature sensor.
Yeah.
I just want to
Okay,
ask
right. Temperature sensor, okay.
why is it they use
The question is?
the parameters for accuracies and temperature and limited temperature is in Celsius, and why is it not in Kelvin? Nitpicky thing.
Yeah, okay. So is that the question?
Yes.
All right. Why is it in Celsius but not in Kelvin? Minus 50 to 150 degrees C. Cornelia?
I found information is more specific on Celsius and Fahrenheit, but they don't use in Kelvin. But if you want to use Kelvin, we can convert it by yourself. Haziq? But
Haziq,
based
okay?
on, is it okay for my answer, Haziq?
Yeah.
Yeah, it's just a unit conversion, right? So you just plug it into the equation and you get the Kelvin.
I thought there is
All right. Any more
something
questions,
more.
guys? Any more? All right. Any more from you, Haziq, or any more from anyone else?
Doctor, I have a question.
Yep, go ahead.
Why emitter is always forward biased?
All right, go ahead. Siapa tadi tanya soalan? Saya tak nampak dekat display ni. Can you introduce yourself?
I am Farhan.
Okay, Farhan. Why emitter, right? Emitter is always forward bias.
Yes.
Okay, anyone from your group, go ahead. Maybe Amirul, would you like to go to the page where you do the biasing of the both junctions? So and explain why emitter is forward biased then.
I think the emitter is always forward biased with respect to the base. So the supply majority charge of the carriers to the base, I think.
Okay. Anyone else would like to add to that, or is okay already?
think
No additional answer? Yeah, anyone? Go ahead.
So when it's forward bias, so the depletion region will become narrow, so it's easy for the carrier to flow.
so the electron will flow into the collector region. I think.
Okay.
You want to get amplification, right?
Mm-hmm.
And you want the magnitude to be bigger, right?
Yes.
Okay.
So
maybe
it is to amplify the current.
is it Amirul and team?
So for this common emitter, we need to amplify the base current, as we can see. So as we amplify the base current, at this this input characteristic, as we increase this, the VVE also will be increased. So when just I thought about it, when we increase the VVE, we also increase the VCB and VCE. So when we increase the voltage in the VCE region, I think it will supply the electron needed to make it a majority charge in the carriers.
All right, thank you.
Right. Any last question? Maybe my last question, right? Okay. What was the typical range of the amplification? So you mentioned about alpha, right? And alpha is the gain, isn't it? So do we have a range of amplification or the gain?
The current gain will be between 0.9 into 1.1 in that region only.
Oh, quite a small range.
Quite yes.
Okay. So do you have any idea in terms of the magnitude of current? How big can it handle for BJT? Is it like in the milliamp region or low ampere or high ampere?
Milliamp to ampere.
Or milliamp to ampere?
Milliamp.
All right, so I guess that's all from this group. So let's give a round of applause to the group. You can do it virtually as well, since we're not in Dewan Kuliah. Right, so thank you very much and good job, guys. So good presentation overall and good discussion as well. So
Thank
it's
you,
already
Doctor.
close to it's already close to 150 though. We'll probably do the second presentation tomorrow then, because the session is so hot and so long, and we discussed quite a bit as well. And I won't be I don't think we're gonna go into the second group now, because that's gonna take at least another half an hour, and it's gonna go into another Q&A as well. So we'll do the second group for JFAT tomorrow, yeah? So Amirul, I want you to convert your file to PDF and email to me, zamir@usm.my, and then I'll share the file on Elan, okay? So that everybody can access accordingly after this. So I think you can also see the benefit of this from the very first presentation. So you covered a little bit of introduction to BJT, to your device, and then the configuration of the device, the operating principle and application as well, but including the companies. So you can now see at least the moment you have seen companies, especially those which are related to Malaysia. In this case, you have seen On Semiconductor in Seremban, Senawang, right? Senawang. And you've also seen Nexperia in just USM, Bukit Jambul, dekat Equatorial tu kan. USM punya building juga. So which actually hosts a couple of other companies there. IC Design pun ada kat situ juga sebenarnya. So which are just around the corner. So you'll see more and more of this. And when it comes to looking for internship later on, so just imagine if you are called for an interview on Semiconductor. Okay, so this is your slide. One of your slides that you can open up and study, just a couple of slides. So you can look from the fundamental, from the introduction, how does it work, how does it look like, and then what do we use the devices for? Just now we've seen temperature sensors, switch and amplifier and whatnot. So you have quite, a spectrum of information already just in 20 minutes of presentation. So this is what I'm trying to do. It works for the previous batch as well, because when it comes for the internship interview and the job hunting, this is what is among their reference. They go back to the assignment, to the presentation slide. In fact, the video, I will upload the recorded video later on. You can go back to this and you boleh khatam balik lah the information before you prepare for the interview later on. It'll be very helpful. Trust me. Okay. So that's all for today. Group 1. Thank you very much. So good job. Done. You're done. So now you can prepare questions for group 2 onwards tomorrow. Okay. So I'll see you guys tomorrow then for group 2 with JFAT. Okay. Bye bye. Take care. Assalamualaikum.
Thank you, Doctor.
Thank you, Doctor.
Terima kasih, Doktor.
No problem. Bye bye.